Hello everybody, today we're going to be looking at Unit 8, Big Idea 1, which involves a multiplication rule. The I can statements that go along with this big idea, or I can use an area model to determine probability. I can compute conditional probability using a table, and I can determine independence among events and apply multiplication rules when events are or are not independent. And the problem we're going to focus on today is this second bullet point right here. So I can compute conditional probability using a table. So let's bring this sheet here. And this sheet is in the description of the video. So you can click on that link and print it out yourself if you want to follow along, if that'll help you. So let's look at this notation first. So this notation right here, hopefully you've already seen some videos where you know what this means, but let's just remind you first that remember that the notation, this right here, probability of event A given that event B, asks for the probability of event A happening given that event B occurs. So I like to think of this as changing the total number of cases, which is going to be your denominator. And we're going to see two examples of this coming up. So let's get to our problem. So we're going to have a set of dice right here. I'm going to put these out for you. So I have a set of, looks like 6 yellow dice, 2 blue dice, and 4 blue dice and 2 red dice. So a set of 6 yellow dice, 4 blue dice, and 2 red dice are rolled, and the amount of even and odd numbers are counted on the table below. So we're going to take some data right here, right now, and fill out this table and find some probabilities. Okay, so here's my roll. We'll just do it like that. Now let's separate by colors. So we'll put the yellows over here, the blues up here, and the reds over here. Okay, so let's look at our yellows. Let's look at how many evens we have. Looks like we have a 2 and a 6, so it looks like we have 2 evens. Odds, we have 1, 2, 3, 4, and our total was 6. Blue, let's look for evens. We have 1, 2, 3 evens, 1 odd, and a total of 4. And then red, even, we don't have any red evens. That's fine. Red odd, we have 2 of those for a total of 2. And then let's fill out our total amount of evens. So we have 2, 3, and 0, which makes a 5. A 4, 1, and a 2, which makes a 7. And then when we come to this total and total, these numbers should add up both this way and this way. This is a 6, 4, and a 2, which makes 12. And this is a 5 and a 7, which makes 12. And that's good because we have 6 yellow dice, 4 blue dice, 2 red dice. We have 5 evens and 7 odds, and 12 total dice. So that's going to be our data set for this example right here. So we're going to find the following probabilities. So find the probability that I draw one of these dice at random, and that dice is a yellow. So what I want to do here is, remember, I'm going to have a fraction. So how many, I'm thinking of how many there are that are this event, how many over our total number of chances. So in this case, my total chances is all these dice here, because I'm just drawing one at random. So there's a total of 12. And the probability that I get a yellow, so how many are yellow? I have a total of 6 yellows, right? So 6 over 12, which is going to simplify to 1/2. And you could also simplify it to 0.5. Okay. Now let's look at the probability that I have a blue dice and I'm even. So let's look at probability of being blue and even. Probability of being blue and even is pretty key here. I have to be both. So I'm not going to be blue or even. I'm going to be blue and even. So this blue odd one right here, this one doesn't count. So blue and even, there's only 3 of these, right? So that's how many there are that fit this condition, blue and even. That is that number there. And then what's my total? Well, I don't really have any conditional probability, so my total should be the total outcome space. It's all of the dice combined. So I'm still 3 out of 12 total dice. I believe I can simplify this to 1 out of 4, or a 0.25. All right, now let's get to our conditional probability here. So this one is a probability that I have a red given that I have an odd. Okay, so I'm only looking at the odd dice, and then I'm going to see how many of those are red. So like I mentioned before, that this given that kind of changes your total. So again, to state this again, I'm looking for the probability that I get a red given that it is odd. So I'm only looking at the odd dice at this point. So my total has now changed. Instead of out of 12 dice, I'm only looking at the odd dice. So my total now is 7 dice. My total is only out of 7. Now, how many of those dice, the odd ones, are red? I have to look up in my table, and I'm seeing a 2 here. So probability of getting a random dice of red, given that it's odd, is going to be 2 dice out of 7 dice. I'm going to get my calculator real quick for this one. 2 divided by 7 is 0.2, and the 8 rounds up to a 9. Okay? And let's look at the last one here. Probability of getting an even dice given that it's yellow. Okay? So I'm only looking at the yellow dice, and then I'm going to count how many of those are in fact even. So I'm changing my total. Instead of out of the 12 dice, I'm only looking at these yellow dice here. It's for a total of 6. Okay? So my total is now 6. And now how many of those are even? Yellow, I only have 2 that are even. So this is going to be 2 dice out of 6 dice are even, which makes a 1 out of 3, which makes a 0.33. Okay, and let's look at that last example more from the dice's perspective. So probability that I get an even given that I'm a yellow dice. So I'm eliminating these from what I'm even looking at, and I'm only looking at these dice. So this is my total amount of dice. That's why there's a 6 there. And then which one of them are even? Well, the 2 and the 6. These are my odds. Those are my evens. So I'm 2 dice are even given that I have these 6 dice selected. So that's where I get my fraction 2 out of 6. Let's look at the prior example real quick as well, just because I like using the dice for this. So I'm probability that I have a red dice given that it's an odd number. So let's get rid of the evens real quick. Let's just work with the odds. Is that right? Sure. So here's our odd dice, right? 1, 2, 3, 4, 5, 6, 7. That's why I have a total of 7 dice. And then how many of them are actually red? Well, these 2 right here. So that's where I get my fraction 2 out of the 7. And that's equal to 0.29. So hopefully that helps out with some conditional probability. Again, the link for this document's in the description below. And thank you very much.